Last class we have covered isometric projections, isometric views. So, in isometric view, the object is rotated by 45 degree about the vertical axis and 35 degree 15 minute and 52 second about the profile axis. It results in why it has been rotated 45 degree about the vertical axis, then 35 degree approximately about the profile axis, because it results in equal amount of foreshortening of the object along the isometric axes. Up to this I have finished up to the last class. Go to this, viewing direction is fixed just in terms of this is a cube and this direction is fixed and it has been rotated with your vertical axis by means of 45 degree. It has been rotated 45 degree, cube is rotated, step 1. So, step 1, all length will be, let us say, length, width and height will be 1 and 1 unit dimensions. Then it has been rotated about the vertical axis by 45 degree. Once it has been rotated by 45 degree, this is the cube how it looks. Then you can see both the faces. So, it will be 1 by root 2 and 1 by root 2 at one side and other side will be 1. Then further it has been rotated at an angle of 35 degree 16 minute about the profile axis, Now, in step 3 the view comes out to be all around length, height and depth all will be foreshortened by means of 0.82 times. It will be shortened by means of 0.82 times, that means equal shorten. So, this is a step 1, all the sides having unit dimension 1 then it has been rotated by 45 degree, then it become 1 and here 1 by root 2 plus 1 by root 2, then it has been rotated by in step 3 about the profile axis it has been rotated. So, it will be 2 by root 6. So, all the sides now seems to be, all the sides has been reduced to 0.82 times. Axonometric views, isometric views, lengths are foreshortened equally in the direction of the 3 principal axes. This please remember, and diametric views, lengths are foreshortened equally in direction of any 2 principal axes. Difference between isometric and diametric views, in isometric views lengths has been foreshortened equally in the direction of 3 principal axes, and diametric views lengths are foreshortened equally in the direction of any 2 principal axes, but not in the direction of 3rd principal axis. Trimetric views, lengths are foreshortened unequally, remember this, lengths are foreshortened unequally in the direction of the 3 principal axes. The difference between isometric and trimetric views, isometric views lengths has been equally foreshortened in the 3 principal axes, that means x, y and z. In trimetric views lengths are foreshortened unequally in x, y and z direction. In diametric views lengths are foreshortened equally in the direction of any 2 principal axes. For example, x and y equally it will be foreshortened. However, in the 3rd axis it is not going to be foreshortened. Procedure for the isometric projection, axis, views and dimensions. Look at here, this is your horizontal plane, this is the case of 3rd angle projections and this is a frontal plane. So, this is your top view and this is your front view, this is your profile view, and I have marked these points here, then these points has been marked, and the axes, principal axis, isometric axis has been marked. It has to be 120 degree angle, it will make 120 degree angle with each other. So, you mark it x, y and z. Look at here. If I mark it here, this and this it is in the front view, then this and this is in the profile view, and this and this is in the top view. Now in the top view it is a depth and width, in the front view generally height and width, and this is the case depth and width. Look at here, depth and width, this is a depth and width, then height and width, sorry, in the front view it is height and width, in the top view it is the depth and width. So isometric width, isometric depth, isometric height. This is a front, this is a right side view, this is your top view. So this is your case of your 3D isometric view. Now how do you start it? Isometric projections. Now prepare a isometric box. One can draw isometric figure with the help of isometric box. This is your isometric box. Then these are all your isometric axes, x, y and z direction. Then isometric projections, this is foreshortened by means of equally foreshortens 0.81 times. Isometric drawing, no foreshortening. Remember, this is the difference. If sometimes some questions it has been asked, go for isometric drawing, in that case it has not been foreshortened. That means all lengths will be equal lengths, or whatever in the view, this will be equal lengths. That view will be projected as equal lengths, but isometric projections, the length will be foreshortened by means of 0.81 times. All lines parallel to isometric axes called isometric lines. All isometric lines are foreshortened equally in terms of isometric projections. This is your 0.81 or 81 by 100. All non-isometric lines may or may not foreshorten, and foreshortening ratio of such lines may vary disproportionately. Projections of parallel lines will be parallel in isometric views. All measurement can only be marked on isometric lines. All measurement, while doing the dimensioning, all measurements can only be marked on isometric lines. Isometric projections versus drawing or views. Look at here, this is isometric projections, this is your isometric drawing or isometric view. Isometric projections are foreshortened because the object is tipped with respect to the viewing plane. How you are viewing? In isometric projections, how you are viewing, depending upon that it has been foreshortened. So isometric sketches or drawings are usually not foreshortened because they will appear proportionate when showing the dimensions full size along isometric axis or lines. It is easier just to sketch the full dimensions. So A is your isometric projections or isometric projection of a cube, that means equally length, width and height equally it has been foreshortened. But B is your isometric view, not foreshortened, it is 100 by 100, what is the exact length, it is there, that length. Now to do this you have to prepare a isometric scale. For preparing this isometric scale in the drawing, you cannot use the calculators. For foreshortening the lengths, all lengths in 3 directions by 0.81 times, you cannot do it by means of calculator, rather you have to prepare by means of drawings. So prepare a isometric scale before going for isometric projections. So at 45 degree, this is your normal scale, 0, 1, 2, 3, 4, you mark it with your scale, 1 centimeter, you can mark it 1 centimeter is equal to 1 meter length. This is 1:1 scale, you can plot it, or 1:10 depending on that, 0, 1, 2, 3, 4. Then this is your regular scale. Then go to isometric scale, prepare it at an angle 30 degree. Then from there, from the regular scale you project it back, and this will be giving, suppose you are giving your regular scale is 1 centimeter, that means you mark it 1 centimeter, then at this point has been projected back to this point. So if you take it 0 to 1 in your isometric scale here, this is your regular scale and this is your isometric scale, automatically it has been reduced to 0.81 times. So for example, means this isometric scale, how you are going to prepare, suppose there is a cube, for example if it is not a cube, it is any shape, maybe in the depth directions, suppose this is your you can say that this is your 2 centimeter, this is your 2 centimeter, then this is your 10 centimeter in the depth directions. So this 10 centimeter, this is your largest dimensions in depth directions. That dimensions you have to take in the regular scale. Then with the regular scale you convert it into isometric scale. That means once you have taken the largest dimensions 10 centimeter in the regular scale, it is obvious that 2 centimeter and 2 centimeter will come into in the regular scale. If you take 2 centimeter in the regular scale, then latter part it will be very difficult to foreshorten your 10 centimeter. So first you prepare isometric scale depending upon the dimensions, then from the isometric scale while doing the isometric projections you take the dimensions. Suppose in isometric scale it is 2 centimeter, that means in regular scale where is your 2 centimeter? This is my 2 centimeter. So this has been projected back. So this to this dimension is your isometric projection scale, it is reduced by 0.81 times. So prepare your isometric scale first, starting your isometric projections. So it has been foreshortened by 81 by 100 or 0.81 times, used in isometric projections only. Isometric drawing, how you are going to start it? By means of boxing method. Object is enclosed in a regular box which is drawn around orthographic projections. By means of boxing method, it has to be enclosed, that means object has to be enclosed in a regular rectangular box which is drawn around orthographic projection. Then box is then drawn in isometric and object is located by its points of contact. We will explain. Offset method, in offset method when object is made up of planes at different angles, locate the points on the base plane, that means isometric plane first, then vertical isometric lines are drawn from these points for a given height dimensions. These are the two methods, one is your boxing method, other is your offset method to draw your isometric projections. So next we will start it. This is all about basics of isometric projections. Next we will solve few examples by means of isometric scale as well as by means of boxing or offset methods. So isometric views, what I have covered till now, all lines parallel to isometric axis is called isometric lines. All isometric lines are foreshortened equally, remember this for isometric projections. All non-isometric lines may or may not foreshorten, and foreshortening ratio of such lines may vary disproportionately. Then projections of parallel lines will be parallel in isometric view. All measurement can only be marked along isometric lines. For dimensioning, all measurement can only be marked along isometric lines. While doing the dimensioning or dimensions can be marked along the isometric lines. This is your important points, you keep it in your mind. Then you start with your procedure for isometric projections. Choose the origin as the starting point. Doesn't have to be the point on the object. Remember, if there is object, not necessarily any point in the object you can take as origin, not necessarily. You choose a choose the origin as the starting point, draw the isometric axis from the origin at an angle of 120 degree x, y and z. Then draw an isometric box corresponding to the maximum object dimensions. As I said, what is your maximum object dimensions in x direction, in y direction as well as in z directions. Then draw an isometric box corresponding to the maximum object dimensions. All object edges parallel to the three principal axes are also parallel to the corresponding isometric axis. These object edges are called isometric lines. All the object planes parallel to the three principal planes are called isometric planes. Draw the isometric edges, planes first. Remember, draw the isometric edge and planes first. Locate key points. Locate key points in isometric drawing. Then draw non-isometric object lines planes using the key points. So, hidden lines are generally not drawn. Hidden lines as far as possible in case of isometric projections are not drawn. Let us start isometric drawing procedure. This is your views, top, front as well as side views. Then take the grid lines, draw first principle is draw isometric box of overall dimensions. That means overall dimensions means these dimensions you measure, these dimension you measure, then this dimension you measure. Start with this. See the dimension I have marked. Then again bottom part it has been marked. Choose your origin. The origin has been chosen. Then this is what? Width directions. This is your width directions. So in the top view, this is your width. So choose it and you take it, this is your width direction. Draw it and take it, what is your largest dimensions? In the width direction, this is your largest dimension, you take it. Then height directions, height is your vertical here, you can take it, this is your height and take your largest dimension here, draw it, then finish it, width and height, then depth directions. Obviously, this is your depth directions, you take the largest dimension, then finish your cube. This is your isometric box. This is your isometric box. First, what I have done it, generally you mark your top view, front view and side view and measure your dimensions, largest dimensions in depth, width and height directions and choose a origin, any point, draw the grid lines, choose the origin. From with respect to origin, draw the three principal axes, isometric axes. This angle has to be prepared with your 120 degree, or you can do it, you can take it here, then you can prepare your 30 degree, or you can take it this directions, you can prepare it. Then once choose your origin and draw the width directions, then depth directions, then height direction, complete your isometric box first. So isometric box has been completed. Then draw isometric lines first. Isometric lines first, then we will go in width directions. In width directions, these dimensions you draw it. Similarly, in height directions, you take the dimension. Then what happen? In again width direction, these are all your called isometric lines. This is your width directions, this is your height directions, these are all your isometric lines. Then this is called your isometric plane. Then draw non-isometric lines. What are your non-isometric lines? If I take it from here to here in height directions, I will find it out this point. I cannot draw the non-isometric lines, rather I mark the points along the isometric lines. What are the points are there? From here to here in height direction in front view, this point has been located. From here to here in width directions at the top view, this point has been located. So, this point has been located, and this to this line, if I draw, this is your non-isometric lines. So, locate the points, then draw your non-isometric lines. This is your non-isometric lines. Then similarly take other part, one by one you take other part and finish this box. Mark the points first, then do it, finish it up by means of your HB pencils, because this is your object line drawn, this is your particularly your construction lines, means object lines. So, this is your construction lines, this is your object lines, it has to be marked by means of HB pencils. Then this plane is called your non-isometric plane. Then once you draw your object lines, then construction lines slowly erase it, or you can put it with a lighter mark. This is your construction lines. If I take it out, how it looks? This is my object, this is your isometric drawing. Now there are two difference, one is your isometric projection, other is your isometric drawing or isometric view. If it is a isometric drawing or isometric view, first of all, for both the cases, forget about isometric drawing or isometric projections. For both these cases, this is a procedure you have to draw. Draw the isometric box first to clear your overall dimensions. That means largest dimensions in width, in height direction as well as in depth direction. Finish your isometric box first, then draw your isometric lines, then draw non-isometric lines by marking points along the isometric lines, marking the points, then draw your non-isometric line as well as non-isometric plane. Then there are isometric view, then there are isometric projections. In case of isometric projections, this length, particularly width, height and depth, it will be foreshortened equally by means of 0.81 times. So, then you have to draw your isometric scale. With respect to isometric scale, suppose this is your 2 centimeter. From there this is your regular scale 45 degree, then this is your 30 degree, with this is your 30 degree. Then you draw the scale. Suppose this to this is your 2 centimeter. From there you project it back. This is your reduced scale of your 2 centimeter. So, with directions, then you mark your 2 centimeter. Similarly, height direction you mark, because it has to be equally foreshortened. Then this view will become a isometric projections. So, isometric view there is no foreshorten, isometric projections there is a foreshorten of all along three axes x, y and z directions. This is all about how to start isometric drawing, the procedure. Measurements, linear measurements can be made on isometric lines. Then lines which are not parallel to the isometric axis are called non-isometric lines. Lines which are not parallel to the isometric axis are called non-isometric lines. Here lines which are not parallel to the isometric lines, these are non-isometric lines. Measurement cannot be made on non-isometric lines. Remember, you cannot measure along your non-isometric lines. Angles specified in degrees do not appear in their true size on isometric drawings. Angles must be laid off with coordinates which are parallel to isometric axes. This is all about your measurements. So, measurement cannot be made on non-isometric lines. So, in summary, measurements, isometric measurements can be made on isometric lines. Remember, measurements cannot be made on non-isometric lines. So, this is all about isometric, how do you start it. So, next class I will start by means of boxing method, where origin is not an object. Few examples we are going to solve it, and step by step boxing method as well as offset method will complete your isometric view as well as isometric projections. Thank you.